Hello guys, welcome to all of you on my YouTube channel. This is Samadhan Kale. So in this video guys, we will learn the practical number 8 of the third year BSc Mathematics of subject Python programming. So before starting today's practical and today's video, if you do not subscribe to my channel, please subscribe it and press the bell icon so that you will get the latest update of videos. And please guys, like my video if you like the content of my video. Okay. So let us start today's video guys. So this is the practical number 8, and which is application of these eigenvalues and eigenvectors, and this is based on the unit 4 of this point 4 point. So guys, this is the practical 8 and this is the title. Now let us take the first question guys. So we have to define eigenvalues and eigenvectors of the square matrix. Okay, so this is the definition that I have given in the mathematics. So eigenvalues are the special set of scalar values that is associated with the set of linear equations and which is most probably in the matrix equations. Okay, so we can find eigenvalues of any matrix by using the equation, that is the determinant A minus lambda I is equal to 0. Okay, and then eigenvector. So the eigenvectors are also termed as the characteristic roots. That means eigenvectors means the characteristic roots, and these characteristic roots can be found by using the determinant A minus lambda I is equal to 0 itself. Okay, so these are the eigenvectors. Now this is the question first. It's very simple. Now let us move to the question number second. Explain the eigenvects function with suitable examples. Now guys, this eigenvects function is in the SIMPy library, so we have to explain it. So with the help of this SIMPy.matrix, we have to first import the library SIMPy, and from this SIMPy library you have to construct a matrix, and then you can apply this eigenvects function on the matrix. That's why it's given matrix dot eigenvects method. Okay, so we can find eigenvectors of the matrix by using this method. So eigenvects method returns a list of tuples of the form. Okay, it will return a list of tuples of the form. So what it will be written guys, let us see. This highlighted point, it will be written. That means first it will be written the eigenvalue, then the algebraic multiplicity and the eigenvector. So these three many you can be get by the output. So syntax is the matrix dot eigenvectors. Suppose we have imported the matrix as A, so you can simply write as A dot eigenvectors. Okay, and then you will get the eigenvectors. So it will return a list of tuples of the form. Already we have seen eigenvalue, algebraic multiplicity, and the eigenvectors. Okay, so let us give the example for this guys. So I will import first the SIMPy library. Okay, so import SIMPy as sy. Okay, now I will construct a matrix A. So A is equal to this sy dot matrix. Okay, and I want to construct a matrix of these 3 by 3 matrix. Okay, so 1 2 and then -1. Okay, this is my first row. Now I'm going to take in the second row 0 3 and 2, and my third row is 1 then -2 and 4. Okay, so this is my matrix A guys. Now I want eigenvectors for this matrix, so I will use this A dot eigenvects function. Okay, which function? Eigenvects function. So it will give me the eigenvects function. Okay, eigenvects, and give the parenthesis. Let's run it. Let's run it. So it will give you guys the eigenvectors. Okay, and so this is the matrix that I have taken randomly. That's why it will give you first the eigenvalues, then the algebraic multiplicity. That means how many times these eigenvalues are repeated. that is only one time. Each and every eigenvalue is repeated one time, and this matrix this matrix is your eigenvector. Yes, so it is again an eigenvector and it's again a eigenvector. Okay guys, so in this way you can get the eigenvectors. So but for writing the output, it will not be convenient for you, so I will take the example which is in simplest form. Okay, so let us take this example, construct this one. Yes, okay, and substitute here. Okay, this is the matrix, and you have to give here is y dot matrix. Okay, and let's run it. So we will get, guys, this is the -1 is the first eigenvalue, and it is repeated one time. So with respect to the -1, we will get, with respect to the eigenvalue -1, we get this is the eigenvector, that is -1, 1 and 0. Second eigenvalue is 0, guys. So 0 is repeated one time. Algebraic multiplicity, that means the eigenvalue repeated how many times? So 0 is repeated one time. So with respect to this 0, I will get the eigenvector, that is 0, -1 and 2. Third eigenvalue is 2, and with respect to this eigenvalue 2, I get this is the eigenvector 2 by 3, 1 by 3 and 1, and it is repeated only one times. Okay guys, I hope all of you understood the eigenvectors. Now next, third example. So find the eigenvalues for the matrix. Yes, so in this example we have to find the eigenvalues for the matrix. So again I will import this simpy library, or from import I will write from. Okay, then import, then simpy, and from import simpy, what we have to, from simpy then import. Okay, I have to write this one. From simpy I want to import this matrix function. Okay, so now you are familiar with all these methods, how to construct a matrix, how to import, and all these things. Okay, there are so many methods we have already learned. So this A is equal to this matrix, and in this matrix you have to construct this 3 by 3 matrix. Okay, so again I will write 3 by 3, and you have to give the elements. Which are the elements? You have 1, 1 and 1, then 0, again 1 and 1, again 0, 0 and 1. Okay, so this is your matrix A, guys. So you want the eigenvalues. So what you will write? You will write A dot eigenvalues. Okay, A dot eigenvalues. Then and only then it will give you eigenvalues. Okay, eigenvalues. This is the function eigenvalues, and let's run it, guys. So you will get the eigenvalues of the matrix. Okay, so which are these eigenvalues? 1 and 3. 1 and 3. If you run it again, so you will get the eigenvalues 1 and 3. Okay, so if you want, you can check it. Okay, eigenvalues, and in this eigenvalues function, it will return what it will be written. Let us see. Compute the eigenvalues of the matrix. Okay, and what it will be written? It will return eigenvalues list or dict. It will be written in list or in the dictionary, eigenvalues of the matrix. Now it will return dictionary. When it will be written dictionary, this 1 is repeated 3 times. This is the algebraic multiplicity. That means this matrix A has eigenvalue 1, but it will be repeated 3 times. It repeats 3 times. Okay, so you have to write this output eigenvalues. So there are 3 eigenvalues, 1, 1 and 1. So why it will be written in dictionary? Because this is the key. Key means 1 is the eigenvalue and it repeats 3 times. Okay. So for let us move to the fourth question. So fourth question, we have to find the eigenvalues and eigenvectors for the matrix. Okay. So for this, I will copy this one. Okay, and paste here. Now I want to construct a matrix A. So I will construct A is equal to this matrix, and I'm going to construct again a 3 by 3 matrix. Okay. So in this 3 by 3 matrix, I want to enter the numbers 1, 2, 2, and then 2, 1, and 2, and again 2, 2, and 1. Okay. And then I will use, now I want eigenvalues and eigenvectors also. Okay. So firstly, I will write A dot eigenvalues. Okay. Eigenvalues. And if I use print statement to it, then what it will be written? Let us see. Let us see. So it will give you the eigenvalue -1. It repeats 1 times. Again, 2 minus square root 7. It repeats 1 time. And 2 plus square root 7. It repeats 1 time. Okay. So it's the eigenvalue. Now I want eigenvectors. Okay. So I will use again the print method for this, and I will use a dot eigenvects. Okay. Eigenvects. Give the parenthesis and let's run it, guys. So okay, print here. I want T. Let us run it. So you will get, guys, this one. Let us see the output. So for the -1 eigenvalue, it repeats 1 times, and you get the eigenvector is -1, 1, and 0. Okay. Now second one. Second eigenvalue is what? 2 minus square root 7, and it repeats 1 times. Algebraic multiplicity. Okay. Eigenvectors functions properties. Okay. Then you will get this eigenvector, which is eigenvector 1 minus square root 7 upon 2 minus 1 by 2 and 1. Okay. This is the eigenvector corresponding to the eigenvalue 2 minus square root 7. The third eigenvalue is the 2 plus square root 7, and it repeats only 1 time. So this is one is the algebraic multiplicity of this eigenvalue. And you will get the eigenvector it as 1 minus 1 by 2 plus square root 7 upon 2 and 1. Okay. So these are the eigenvectors for the given matrix. Okay. Let us move to the fifth question, guys. So let us take the fifth question. Again, we have to find the eigenvectors and okay, here eigenvalues and eigenvectors. That it should be eigenvalues and eigenvectors. Okay. So I will correct it. Okay. Eigenvalues. Okay. And then eigenvectors. So I will construct now matrix A. So what is matrix A, guys? So A is equal to, I will write it as matrix, and in this matrix I'm going to construct again a 3 by 3 matrix. Okay. So in this 3 by 3 matrix, you have to take 1, 2, 3, and then 3, again then -1 and 1. Okay. And then 1, 1, and -1. So this is my matrix, guys. Now I want what I want. I want eigenvalues and eigenvectors. So I will print a dot eigenvalues. Okay. Eigenvalues. And in the next, I will print a dot eigenvectors. Okay. So a dot eigenvectors. Eigenvectors. So in this eigenvalues and eigenvectors function, I will get the eigenvalues and eigenvectors of the matrix. Okay, guys, it's a very big. Okay, it's a very big output that you have to return. Yes, so it's a very big. So you can pause the video and you can take it. Okay, so I will stop here. Okay, so what is the first eigenvalue, guys? Let us see. This is the first eigenvalue. minus 1 by 3 plus 34 upon 9 into square root of 3945 upon 18 plus 439 upon 54 in raised to power 1 by 3 plus this one and so on, and it repeats only one time. Okay, so this is the thing that we have to remember. And then yes, this one eigenvalue again, where it's starting from here to here. Okay, so it's the second eigenvalue, and it is the third eigenvalue. Which one? This one. Okay, this highlighted is the first one. Then from here to here, second one. Okay, and from here to here, third one. Okay, so you can pause the video and you can write the output. Okay, so for this first eigenvalue, this is repeated only one times, and you will get this matrix. This is the matrix, guys, and this matrix is eigenvector. Okay, so I will take lightly down. Okay, you can pause the video again here and you can write the next output. So this is the second eigenvalue, guys, and for this second eigenvalue you will get, this is the second eigenvector. Okay, now this is the third eigenvalue, and for this third eigenvalue you get, this is the third eigenvector. Okay, I hope all of you understood. This is a very big one. Yes, now I'm going to take the sixth example. Okay, and in this sixth example again I want to construct a matrix A, so I will construct this matrix. Okay, and it's again a 3 by 3 matrix. Okay, 3 by 3 matrix, and in this 3 by 3 matrix all entries are 1. So 1, okay, then 1 1 1 1 1 and 1 1 1. And then I will write print this A dot eigenvals, and then I will print A dot eigenvectors. Okay, A dot eigenvectors, and let's run it, guys. What we will get? We will get these eigenvalues, these 3 and 0. These are the two eigenvalues, but 0 repeats 2 times. Okay, so for this 0 2 times, this is the matrix minus 1 1 and 0. Okay, and minus 1 0 1. These are the two eigenvectors for the 0 eigenvalue, and for 3 eigenvalue we will get this vector 1 1 1 as the eigenvector. Okay, I hope, guys, all of you understood the practical number 8 of the eigenvalues and eigenvector. Okay, so you can write these outputs on your practical sheet. So thank you for watching the video.